LAN architecture. In this video, I'm going to talk about local area network or LAN architecture. You know that in previous videos, we have talked about many topics related to the LAN. We have learned about the Ethernet and different versions of the Ethernet, such as fast Ethernet, gigabit Ethernet, 10 gigabit Ethernet, and so on. Also, we have learned about the media, the layer 1 media that we have on the LAN, today's LAN. For example, we have learned about the twisted pair cables and also about the fiber optic. And also you have learned about the Ethernet frame. You know the content of the Ethernet frame, such as the source MAC, destination MAC address, type field, and also the SFD field, and also the preamble field, and also FCS field. After that, we have learned about the VLANs and trunks, about the broadcast domain, collision domain, and many other topics related to the LAN in the level of the CCNA class. And also let me to emphasize that you will learn more than this about the LAN in the higher course, such as the CCNP courses. But in this video, I am going to talk about the architecture, not about the configuration. What is the architecture? I am going to talk about different levels of, for example, network device, network switch, and the name of them, the responsibility of them, and some other topics related to the design. You know that in the enterprise courses, we have some special courses exactly for design, and you will learn more than this about the design in that courses. But here we are learning only some special and some maybe most important topics about the LAN. In the future, you will learn more than this about the LAN and also the design. First, let me to review the history of the today's LANs. You have learned about this history in the previous video, but here I'm going to review them because I want to give you more information about the LAN architecture. Look at the picture 1. In the picture 1, you can see one simple LAN. In this simple LAN, we have a shared media, okay, and also we have 4 computers, 1 server, 1 printer that connected to the network. This is a simple LAN, or maybe most simplest LAN that you have seen now. Here, as you can see, we don't use any switch. Because of that, all of these devices are working on one collision domain and also on one broadcast domain. This means that these devices need to enable CSMA-CD for preventing or reducing the numbers of the collision, as you have learned before about the CSMA-CD. After that, you know that because here all of these devices are maybe it's possible to experience collision with each other. All of them are working in one collision domain, and also the broadcast of these devices can reach to each other. All of them are working in one broadcast domain. How we can create this type of network? You know that this is the legacy network, and we don't create this type of network today, but maybe you heard before that in the old days we had some topology such as the bus topology. In the bus topology, okay, this is the bus topology, oldest topology of the network, okay, and today's we don't use the bus topology. In the bus topology, we have used the coaxial cable, okay, some type of coaxial cable, and also some special components such as the terminators at the both ends of one, for example, media. And after that, this is the terminator. The terminator actually is one, for example, resistor that should absorb the remaining electrical signal in the line. Okay, it is not important for now to learning about the bus topology because the bus topology is a legacy topology. Only I'm going to review some of the topics. Here we had one terminator. Here we had another terminator, and also we have a special type of connectors. We call them the T connector. With the T connector, okay, because T connector shape is like a T, we can or connect for example, the line to the PCs to the other devices. Actually, in the bus topology, we have used the T connector, and also one end of the T connector connected to the PC, and another types to another sides of the T connector connected to the line, like for example here, as you can see. Okay, and the PC and some other devices can use this T connector to connect the network. This is a simple technology topology that we have used before, but today's we don't use it. This is the same collision domain and broadcast domain. It is not important for us, but another type of the single collision domain and broadcast domain is using the hub. Let me to show you here in the packet tracer. I'm going to add one hub. This is the simple hub, and also let me to add, for example, for PC1, PC2, and PC3, and also if you want you can add one server. This is a server. If you connect this hub to the PCs, okay, we will have exactly this topology. Maybe you say that here we don't have any hub. Yes, this is logical diagram. In logical diagram, maybe we don't need to for example, use all of the transparent devices such as the hub. Because of that, this is a network with single collision domain and with single broadcast domain. You know that the hub floods all of the received traffic. Because of that, if the PC0 is sending traffic, let me to show you where the 192.168.1.1 is the IP address of this PC, and also this PC1 has IP address of 192, for example, 192.168.1.2. Look at here, when the traffic from PC0 is sending to the 192.168.1.2, we have for example connectivity, but in the simulation, you know that if we filter, for example, ICMP, we will see all of the frames should be flooded. Look at here, this is the ICMP echo request. This should be flooded. This means that now exactly at the same time, if the other system sending traffic, we will encounter with the collision. Okay, and also you know that here all of these systems are residing in one broadcast domain and also one collision domain. And this means that in the first days of the network, the network was not so efficient. Why? Because we had collisions, and also the broadcast domain can be extended to 1,000 computers or more than this, and this means that we didn't have any option, any tools to reduce the size of broadcast domain or increase the numbers of the broadcast domain. Because of that, this network is not efficient, you know it. Okay, after creating the switch, you know that in the for example picture 2, you can see that now we are using the switch can divide the network into the multiple collision domains. Here you can see that we are using switch. I have explained this before. With switch you can create multiple collision domain in each port, in all of the ports. Actually, in each port we have one collision domain. This is the collision domain 1, or CD1. This is the collision domain 2, okay, CD2. This means that between the ports of the switch we don't experience the collision, you know it. This is the collision domain 3, this is the collision domain 4, okay, and after that this is the collision domain 5, and finally we have collision domain 6. Actually, we can say that if a switch has 100 interface, okay, we have 100 collision domains. So easy. And you know that this is the benefits of the switch, one of the most important benefits of the switch. And also you know that the switch by default flood all of the broadcast frame to all of its interfaces except the incoming interface. For example, if PC1 sending broadcast, this broadcast should be flooded to the other interfaces. And you know that, as I mentioned before, as I explained before, this is not so suitable for large network. If you have, for example, 50 switch and maybe for example 500 or maybe a little less, a little more computers, all of these computers are receiving the broadcast, and this is not good. I have explained them before. Here we are reviewing only. Because of that, you know that all of the interface of the switch by default are working in one broadcast domain. Okay, look at here, this is our scenario. In this scenario we can replace the hub with one switch. Let me to show you the next step. This is the next step. Now the hub replaced with one switch. Again, we can use, for example, for 3 PCs and also one server. Let me to show you. Okay. After that, we can connect it. I'm going to show you what is happened in the networks and how today's networks are creating, and because of that we can better understand the functions of different things in the for example network. This is the same scenario, but now in this scenario, as you can see, I am using the switch. Again, let me to assign one IP address to PC3 192.168, for example 1/24, and the PC4 again 192.168.12/24.255.255.255.0. Look at here. Now, if you send traffic here, you can see that we have reachability to the 192.168.1.2 without any problem. And if you go to the simulation mode, you know that the switch should forward for example, traffic only to the specified ports, only to the destination receiver port. Look at here. This is the function of switch, more efficient. But you know that if the PC3 is sending one broadcast, for example, if you check the connectivity with the 192.168.1.3, the first thing that should be created is the ARP request. Let me to capture the ARP request also. Again, sending the traffic from the PC3 to the 192.168.1.4. Okay, this is the PC3. Okay, ping 192.168.1.4. We should send traffic to the 1.4. Very good. Look at here. In the simulation, we should send. Here you can see the ARP request. As you know, the ARP request is flooded because this is broadcast, and this means that the switch by default doesn't limit the broadcast, and all of the interface on one switch is residing in one broadcast domain. Okay, and we need to control the broadcast domain size with the concept of VLAN. You have learned about the VLAN, and you know that what is the VLAN. But before talking about the VLAN, you know that in the hub topology and also in the for example switch topology, in these two topology, we are using actually the star topology. Why? Because you know that in a star topology we have one central device and some devices that connect to that central device. Because of that, with the hub and switch, both of them we are using the star topology. When you are using hub, you have one collision domain and also one broadcast domain. When you are using the switch, you have multiple collision domains and only one broadcast domain. But you know that with the define of the VLAN, as you have learned in this class, for example, completely, we can reduce the size of the broadcast domain and increase the number of the broadcast domain. For example, here you can see this switch has 3 interfaces. Let me to show you. For example, this is the interface 1, fast Ethernet 01, fast Ethernet 01. This is the for example, fast Ethernet 02, and this is the fast Ethernet 03 interface. And here we have for example, fast Ethernet 04 and then fast Ethernet 05. You know that by default, all of these interfaces are residing in one VLAN or VLAN 1, and because of that, all of them are working in one broadcast domain. But with definition to VLAN and assigning the VLAN to VLAN 1, the VLAN 1 to port 1, 2, and 3, and the VLAN 2 to port 4 and 5 and 6. Finally, we can say that we have 2 VLAN, and each VLAN is a broadcast domain. And this means that now we are reducing the size of broadcast domain, and you know that this can give us the benefit of controlling the traffic. This is one broadcast domain, and this is another broadcast domain. You know that again here we have 6 collision domains. Each port is a collision domain, but about the broadcast domain, now we have 2 broadcast domain. The switch by default has only one broadcast domain. If you need to create a broadcast domain, you should configure it. You have learned about it. Also, as you can see, in each broadcast domain, we are using one range of IP address differently from the other broadcast domains, because you know that finally between the VLANs, between the broadcast domains, we need to configure inter-VLAN routing, and inter-VLAN routing needs to, the networks are using the different range of IP address. Okay, this is the history until the creation of the VLAN. But you know that we have many devices in one network. For example, maybe you have multiple switch with multiple hosts connected to that switch. Okay, how we can connect switch together? In most cases, we are using a two-level or a two-tier hierarchy. Why? Because, for example, assume that we have switch B with multiple VLANs, switch C with multiple VLANs, again switch D, again switch E, and we need to connect all of these devices together. Because of that, we need a higher level switch to connect these switches together. Because of that, after the, for example, growing the networks, for example, we have used the higher level in the switching, in the switch design in the LAN architecture, and now we have a two-tier, for example, design. Look at here. This is the two-tier design or two-tier hierarchy, or maybe two-level hierarchy. All of them are correct. Let me to write here two-tier design. Okay. Or maybe you see two-level design, or maybe two-tier design. All of them are correct. Okay. After that, here in this design, you can see we have some switch that these switches are connecting to the hosts, and also we have one switch, the switch A, that its function is the connecting for example, switch B and C together. Not the switch A does not connect to the for example, host. Okay, in the design of the LAN, we are calling the switch B and switch C, okay, the access layer switch. Here we have two access layer switch. This is one access layer switch, and this is another access layer switch. Why we should call them access layer switch? Because they are connecting the hosts of the network to the network. This means that we are giving access to the host to connecting to the network. Actually, we can say the access layer switch provides a connection point for end user devices to the network, and does not forward frame between two other access switch under normal circumstances. We don't forward traffic directly between the two access layer switch. We are using another layer, the higher layer. This higher layer name is the distribution layer switch. You know that the function of the switch A only is distributing traffic from one access layer switch to another access layer switch. Because of that, in the distribution layer, we are providing an aggregation point for access switch, providing connectivity to the rest of the device in the LAN. For example, with distribution switch, you can connect to the other device in the LAN and forwarding frame between the access layer switch, but not connecting directly to the end user devices. You know it. Because of that, until now, we have learned the history of the LAN, or for example, the local area network, until we reach to the two-layer hierarchy or two-tier design. Okay, but again, maybe we encounter with another layer. Let me talk about that. Until now, from the same one collision domain, one broadcast domain, we have received to the multiple collision domain, one broadcast domain, again multiple collision domain, multicast broadcast domain, and finally the two-tier design. Okay, now you know the history. Let me to continue the story of the LAN architecture. Okay, in the left side, you can see again the two-tier hierarchy or two-tier design. We have switch B with multiple VLANs, VLAN 1 for computer, server, and printer, VLAN 10 for voice VLAN for the IP phones, VLAN 2 in switch C for computers, and VLAN 20 is the VLAN for the IP phones again, or voice VLAN again, in the switch C. Okay, and now we have a higher level switch, the distribution layer switch. Okay, actually you have this single line diagram, distribution layer switch and also access layer switch. You know that now we have multiple access layer switch and maybe one distribution layer switch, but you know that the network is growing day by day, and after growing, for example, the network to have multiple, maybe more than 50, 100 access layer switch, maybe we need a other higher level. Why? Look at here, we have some access layer switch here with one distribution layer switch, again other access layer switch here with one distribution layer switch, and now we want to connect these two distribution layer switch to each other. Let me to give you one real example. Assume that here we have a building. This is the building 1. Okay, in building 1 we are using the for example one distribution layer switch and also multiple access layer switch. This is the building 1, and also in the same place, in the near place, okay, we have another building. Assume that here we have a office park. In this office park, that is that we are working in this for example office park, we have 2 or maybe more than 2 buildings. Okay, all of them are on the ownership and of the, for example, one company. In this office park we have 2 buildings, building 1 and also building 2. Okay, in each building we have the network, the LAN, okay, including one distribution layer switch and also multiple access layer switch. Now we want to connect these 2 for example building to each other, these 2 networks of the buildings to each other. The one method is using the higher level for example core switch. Okay, with this core switch we can connect the different networks in the, for example, multiple buildings together. Because of that, now we have a 3 level of the hierarchy. The name of this 3rd level is the core layer. Okay, core layer is the layer higher than the distribution layer. In the core layer we are aggregating traffic of distribution switch in very large campus LANs. Here we have a campus. Okay, what is the campus? Let me to give you one definition. This is a campus LAN. You know about the definition of the LAN. What is the LAN? LAN, or local area network, is a network with the residing in a small area, for example in one building. Okay, this is one LAN, this is another LAN. When you have you are using multiple LANs near each other and you are connecting these multiple LANs, for example in one office park, and connect them to each other, now we have a campus LAN. Okay, or maybe in some references you can see the term of CAN or campus LAN. Okay, this is a large LAN, not anymore. After that, you know that here now we have the core layer. The core layer should aggregate the traffic of distribution switch in very large campus LANs, providing very high forwarding rate for the larger volume of traffic due to the size of the network. You know it. You know that with the only function of the core switch is not connecting the distribution switch and maybe the all of the network together. Why? Look at here. In most cases we are connecting all of the WAN connections to the router. Assume that here we have a router. This router is a router that we are using it for the connecting to the for example internet. Okay, because of that this router should connect to the core switch. Okay, and after that now we can configure this router to connect to the ISP's router, and after that we can receive the internet from the this router, the edge router, and after that all of the computers in the LAN, okay, can connect from the core switch to the router, edge router, and then to the ISP. Also maybe you are using the other routers for connecting the campus LAN. This is the campus LAN to the other branches. You know that in each company we have some branches in some other places, another city, another country. Okay, because of that, for these routers, okay, again we should connect them to the campus core switch. Okay, and here now we have for example the WAN of the branches. Actually the core switch is the central point for connecting, for sending traffic between all of the access switches in multiple buildings, and also to the internet and also to the WAN. Because of that we call it the core switch, and the most functionality of the core switch is the high forwarding throughput. Okay, because of that now we know that in some larger campus we need to use the 3 tier or 3 level of design. You know that in the first days we had used only the two-tier design, but now you can see that we are experiencing the three-tier campus design. Let me to write here. Here now we have a three-tier campus design, okay, but here we can see a two-tier campus design. Both of them can be experienced in today's networks. In smaller networks, smaller LANs, we are using the two-tier campus design. In the larger campus, we are using the three-tier campus design. Okay, this is the function of the two-tier and also three-tier networks. But let me to give you a little more information about for example, design of one LAN. In this picture, you can see three buildings, the building 1, building 2, and building 3, as you can see. And in each building, we have, for example, 1 or 2 distribution layer switch. This is the distribution layer 1, distribution 2. And here it means D11 means distribution of the building 1. And this is the first distribution, D12, distribution of the switch in the building 1 and the second switch. A11 means access in building 1, and this is the first access, second access, third access, and also fourth access. The question is that how we can connect these three buildings in one campus LAN to each other. You know that here actually we have one office park, one campus. In this campus we have a three building, and in each building we have a switch block. Okay, this is the one switch block. What is the switch block? Let me to give you definition. For combination of the switch and the distribution switch and also access layer switch, we have a term, we call it switch block. Actually, we are connecting the switch blocks together. How many, for example, way is available for connecting different switch blocks to each other, multiple switch block to each other? For example, here we have 3 switch block and we want to connect these 3 switch block to each other. In a smaller numbers of the switch block, for example, 2 switch block or 3 switch blocks, and also with the limited number, limited volume of the traffic, we can connect directly these switch blocks to each other. Here you can see one mesh topology. Okay, why? Because the D11 now is connected to all of the other distribution layer switch, again D12 to all of the other distribution switch and also other distribution layer switch. Okay, because of that, here we can see between the switch blocks, okay, we are using the full mesh topology. This is the full mesh. Okay, and you know that for full mesh we need multiple interface and also multiple links. You know that we have a formula, n multiply n minus 1, n is the number of the distribution layer switch, divided to 2 is the required, for example, connection. For example, here we have 6 switch block, 6 distribution layer switch, 6 multiply 5 divided to 2 equal to 15. We need to have 15 links between for example, switch blocks, and this means that only for smaller networks we can use this method. This is the collapsed core. Okay, this is the collapsed core of design for connecting the different switch blocks to each other, and only we are using the collapsed core when we have a lower number of the buildings, and also for example when we don't have many traffic between the switch blocks or between the buildings. Okay, why we should call it the collapsed core? Because here you don't use for example third layer. You know that here we are using the 2-layer hierarchy, distribution access, distribution access, distribution access. We don't have the 3-layer. Here we are using a 2-layer approach for connecting different buildings together, and because of that, this is the collapse core. We don't have a real core. We are using the collapse core. This is like a collapse core. Let me to show you the next available design for connecting multiple buildings to each other. We call it the a dual core, or maybe the 3-tier building design. Here you can see that we are using a 3-tier, not the collapse core. This is the 3, okay, a tier design, or 3-tier building design. For example, let me write here building design, And in other term, we can call it the, for example, dual core design or core design. Okay, why? Because here you can see that we are using the core layer, the third layer. Here we have building 1, building 2, building 3. We are using another level, the core. With the core, we can connect the different, for example, switch blocks to each other or different buildings to each other. In this method, we have more flexibility, and also we can forward more volume of the traffic. The reason is that you know that in core switch we have multiple interfaces, maybe more than 100, 200, 500 interfaces, and because of that, and also we have high throughput rate in the core switch. You can easily extend the for example, the 3 building blocks to 3 building network or 3 switch block to, for example, 10 building and 10 switch block. Okay, because of that, when you are using more than 3 or 4 building networks, you want to connect them together, and also you need high throughput of data rate. It's better to using the for example, the three tier building design. Don't forget that we have other options for design of a campus, but here we are only reviewing the for example, more important types. Because of that, until now we have learned about the LAN architecture, about the access layer switch, the function of the access layer switch, and also the distribution layer switch. Okay, now you can understand these terms easily, and after that you know the function of the core layer switch. And finally, you have learned in one campus network or campus LAN how we can connect multiple buildings together. The first method is the collapsed core, and the second method is the collapsed core actually is the 2 level, okay, or 2 tier building design. We call it the collapsed core, another name. Okay, but we have the next method, 3 tier. Okay, in the 3 tier we are using the dual core method, or maybe the dual core building design. Also, let me to give you a little information about the structure or the topology of the switch. You know that in access layer switch, okay, in access layer switch we are connecting the switches, okay, each switch to multiple systems, multiple hosts. Okay, actually we can say that in the access layer switch, okay, between the access layer switch and the clients, this is the here we have multiple PC, multiple for example other devices. Okay, here we are using the star topology. Okay, this is the simple star topology. One centralized device, this is the switch, and also the switch connected to the other clients. But between the switch, the access layer switch and distribution, we can use a different topology. Look at here. Here we have the switch 1 connected to these two distribution switch. Why? For redundancy and for load sharing. Maybe one of these links is failed. Okay, we can use the other link. Here, as you can see, between the access layer switch and distribution layer switch, we are using the partial mesh, not the full mesh. Look at here. Why? You know that here we don't have connectivity between 2 access layer switch. Here we are using the partial mesh. Partial mesh means only the switch A to 1 should connect to some of the for example switch such as the distribution layer switch, not the other devices. But in the core layer, in some cases we are using the partial mesh, and in some cases we are using the full mesh. You know that this is related to the cost, and this is related to the requirement, some of the requirement. And for example, in the layer between the access and distribution switch, okay, if you use the full mesh, it is not suitable for the network, and also it gives it maybe you need to consume more money. Why? Because we don't want to send traffic from the PC to the A21 then to the A22. Because of that, it is not recommended to connecting the A21 to the A22. You need to only use the partial mesh. This means that in all ways the full mesh is not better than the partial mesh. Okay, in some cases partial mesh is better, and in some cases the full mesh is better. You should, as a designer, select which method is better for your network. Also, here we can see that in access layer switch we are using the star topology, and between the access layer and also distribution, we are using the partial mesh topology. You know that maybe in the access layer switch, you think that here in one side we are using a star topology, in another side is the partial topology. Because of that, in some references we can see the term hybrid topology. This means that the access layer switch is working in hybrid topology, and the distribution layer switch in, for example, partial or full mesh topology in the side of the core switch, and also in the side of the access layer switch it uses the partial mesh. Maybe the distribution switch is using the for example, hybrid, in one side partial, in another side full mesh. But if in both sides are using the partial mesh, actually we can say that the distribution switch now is working with the for example, partial mesh topology. Until now, we have learned about the campus LAN, okay, or campus LAN topologies and some of the terminology that we have in the campus LAN. Now, let me to give you a little information about the small office, home office network, but also let me to emphasize that in the previous videos, in the first videos of the CCNA, I have explained the SOHO or small office, home office. Here I'm going to review it. And also don't forget, here is not a class of design. We are only reviewing some of the LAN architecture, some of the terminology, and this can help us for example, using this terminology, this knowledge for implementing the scenarios until the level of the CCNA. In future, in the design courses, in the professional design courses, you will learn more than this about the design concepts. Okay, let me to talk about the small office, home office, and also the devices that we are using in the small office, home office, or SOHO network. You know that LAN architecture is related to the LAN design, okay, or LAN component on the enterprise, okay, and also on the smaller places such as the, for example, one simple office with a little number of the employees, and also maybe a home. This is the SOHO. We call this type of small networks small office, home office. You have learned about the SOHO, but in SOHO, in most cases, we don't use, for example, the individual router, individual switch, individual access points, maybe individual firewall, and some other things. You know that. Assume that here we have a small, for example, office. In this office, we have only 4 employees, and we need to have connectivity to the internet and maybe to one of the corporate branch, corporate main office. Okay, how we can for example, use the devices, the multiple devices to connect to the internet and also to the headquarters. It is so easy. You don't need to buy one router, one switch, one firewall, one access point, or some other things. You can easily for example, buy only one device, such as a small office, home office router. This is a small office, home office router, and in this device, actually, we have multiple devices. Actually, this is a composite device. In this device, this is not only a router. This is a combination of multiple devices. Let me to explain the component and different part of this small office, home office router. Okay, for example, in this device, you know that we should connect this device to the phone line or to the Cat-V cable, okay, according to the ISP or the internet service provider that you have in your area. Okay, and after that, this is the internet service provider, and we are connecting the service provider to the for example, this device. After that, we need to use some devices inside this SOHO router to connect to the internet. For example, assume that in our home, in our office, we have 4 for example, PC, and maybe 3 of them are using the wired network interface card. 1 of them, or maybe 2 of them, are using for example, the wireless network interface card. Okay, because of that, actually we need to have a switch and a router and one access access point. Look at here. Here we have the internet connection, for example, DSL, digital subscriber line, and here we have the ISP connected to the internet, and this is a DSL line. Okay, we need a device. With this device, okay, we should have one switch, at least one switch, because some of the PCs that are working in this Soho are using the network interface card with a wired network interface card, and we can connect the switch to the for example these PCs. Okay, and also we need one AP or access point. You know that access points in most cases should connect to this switch. For example, here you can see that we have one AP. Okay, and this AP is connecting to the for example switch, and after that the wireless clients can connect this AP, and after that with the AP can connect to the switch or the DS. Okay, this is the requirement of us for establishing connectivity between the wired and wireless clients and internet, and also the WAN. Here also we have some wireless PCs, some wireless client. Let me write here wireless client. That's it. Okay, these wireless clients can use this AP to the connecting to the router, after to the switch. After that we need to have a router, because we need a device. This device can have one interface on the inside network and one interface in the outside network. You know that in some cases, for example, we are using the router for some special tasks such as the NAT or network address translation, because inside of our home we are using the private IP 192.168.10/24. This means that one of the range of RFC 1918. Okay, and also the router now should use the NAT feature or PAT feature, port address translation, to converting the private IP to the public IP. And also the router can have multiple types of interface. For example, one DSL interface and one Ethernet interface. Inside we need the for example the router, because the router is supporting multiple types of interface, Ethernet, and this is maybe for example DSL interface, or maybe if it is fiber, we can use again Ethernet fiber interface, fiber Ethernet interface. And this means that at least we need some of these devices. But let me to say that in some cases maybe you need another type of device. For example, you want to have the firewall. Okay, and instead of buying a firewall, it's a good practice to using the firewall and router in one device. For example, this is the firewall. Okay, how we can for example use these devices or create these devices. Also, you know that the router should connect to the one modem. Okay, one DSL modem or cable modem, and after that the modem can connect to the router. Okay, how we can, here we have DSL interface on the modem, and on if the modem is internal in the router, you can connect the DSL line to the router itself, but in external we need a modem. And here if you are using the external modem, you can connect modem to the router with one Ethernet interface, such as this scenario. And actually we can say that we should have one for example device with different capabilities. For example, here you can see that we have one box. In this box we have multiple devices: a modem for terminating the DSL line or the cable TV line. Okay, after that a router for NAT and also some other functions, such as converting the for example to Ethernet to each other, to Ethernet frame to each other, between the private IP and public IP. We need to have NAT to get here. You know that in most cases we are receiving one IP address from the DHCP service of the internet service provider or ISP. Here we have one public IP, here we have one private IP. We need a router to translate between them. And also in some cases the router also itself should give to the inside of the network the private IP address. Actually the router is a DHCP client for receiving IP from the ISP, and also it's a DHCP server for giving the IP to the inside of the network. for acting as the DHCP server, this is a DHCP server with the private IP address, and for acting as the DHCP client, it is receiving the public IP address. Actually, we need a router for many functions. Also, we need a switch for wired connection and one AP for wireless connectivity to the, for example, to giving the wireless connectivity to the wireless client. Actually, we can say we need one device. Okay, we need multiple device: modem, router, switch, AP, and maybe firewall. Okay, because of that, if you want, you can buy all of this device individually. It is consuming a high cost. Why? Because each device has more capability than you need. Okay, and these devices, normal devices with individual capability, are only using for the enterprise's LAN. Okay, you are using all of them in one small, or for example, office, home office, such as a home, such as a office. Because of that, you need to pay more cost. You can buy one small office, home office router. Maybe you are calling this device wireless router. Okay, wireless router or a small office, home office router, both of them are same. In this device, we have actually multiple devices. In this box, we have multiple devices. Look at here. We have a cable modem. We have a firewall. We have maybe this firewall is software firewall. It's okay. We have one router, one switch, access points, and you can connect the wired client to the switch, wireless client to the AP. Here you can see this device. For example, in this device, first we have one interface. This is the interface of the modem. Maybe the modem is residing in this device because you are actually connecting to the modem. After that, there's ISP to the modem. It has one console interface for configuration. It's okay. Here we have for example, wired connection for RJ45 interfaces, and this is these are the interfaces of the for example, switch. And also inside of this device we have one AP. That AP propagate RF or wave, and don't forget this AF is this AP is configuring in the autonomous mode. You know that we can configure one AP in two mode: autonomous mode and also the lightweight mode. Here we don't use WLC, wireless LAN controller, for configuration of the AP. We should configure this device individually because of that this AP is working in the autonomous mode, and because of that everything should be configured individually on this device. Also here you can see one of these ports connected to the switch. If you want, you can connect this switch to other switch for more for example, interface. Actually, in the SOHO, in the small office, home office, in most cases we are using one device with multiple capability. For example, inside of this device, we have one Ethernet switch for the wired Ethernet connection. We have one wireless access points or AP to communicate with the wireless devices and forward the frame to from the wired network. You know that the function of the AP is converting translating the 802.11 frame to 802.3 frame, means the Wi-Fi to Ethernet and also the Ethernet to Wi-Fi. Okay. Also a router to route IP packets from the LAN to WAN or from the WAN to the LAN, and also some functions such as the NAT, such as the giving the IP to the inside of the network. And also maybe a firewall, which often defaults to allow only clients to connect to the servers in the internet, but not vice versa. In Cisco, we have many type of the small office, home office router that we should select one of them for our SOHO according to our need, according to our throughput of data, or maybe some capabilities that we need. But finding the suitable small office, home office router in Cisco products is not so hard, because we have some, for example, requirement, and after that we can compare our requirement with the capabilities of the SOHO routers, and after that we can easily select one of them, and after that with one device you can use all of your functions in your home. Okay, and this is so interesting. You don't need to buy a router, buy a switch, buy one access point, and also maybe firewall and maybe a modem. Okay, you need to buy only one device easily. After that, after connecting the device with some, for example, graphical user interface, or in some cases command line interfaces with some little command, okay, little number of command, you can easily configure that device, and finally you will have one complete network in your Soho. Because of that, this is one of the useful and also interesting devices that we can use it. Very good. Now let me to talk about the one technology that we can use it. The name of this technology that we are using this technology today is in our networks, in LANs, in our LANs, okay, is the PoE, or Power over Ethernet. Okay, let me to talk about the PoE, or Power over Ethernet. What is the PoE? What is the Power over Ethernet? You know that in one network, for each device, we need to have power. For example, for the PC, for the, for example, switch, for the router, and for any other devices, we need some amount of power. This is the PC, for example, and then server, and then switch, and then router. You know that in traditional networks, we are using the AC power, okay, the power of our building for supplying the needed power for these devices. And you have used the power or AC power for example, working in your network. It is okay. But in today's network, we have newer devices. We have new type of devices that for supplying the power for these devices, we have some problems. Let me to a little talk about, for example, these devices. After that, we can learn about the PoE, or Power Ethernet. For example, you know that in today's networks, we have IP phones. What is the IP phone? IP phone is one device, is a, for example, one phone that this phone can convert our voice to the packet. Actually, you are, for example, speaking in the IP phone, okay? And after that, IP phone creates packets from your voice and send these packets to the internal of network in the concept of the voice over IP. You will learn about the voice over IP in the future courses, not in the CCNA, but you know that we have IP phones in the networks. An IP phone needs power, you know it. How we can supply the power of the IP phone? It's so easy. You can use the AC power, okay? Here we have one adapter, and with this adapter, you can convert the AC to DC, okay? And finally, we have the power of the IP phone. Look at here. This is the packet tracer. In packet tracer, let me to add one IP phone. This is the, for example, our IP phone. And after that here, if you click on the IP phone, you can see the back panel of the IP phone here. At the back of the IP phone, you have one AC adapter input. And if you want to use this IP phone, you need to connect this adapter to this, for example, input of the power. Look at here, assume that we have one switch. This is our switch. I'm going to connect the switch to the IP phone. Look at here. This is the connection between the switch and IP phone. Because the IP phone now is is off, the traffic cannot send from the IP phone to the switch. How we can enable the IP phone? We should give power to the IP phone with this adapter. Look at here. I'm going to attach it to this interface. After that, now we have connectivity with the IP phone to the AC power. This is a converter. This should convert the AC power to the DC power. And finally, we can use the IP phone. Now this is working. Because of that, for IP phone, we need to give power and with the, for example, one AC adapter. This is the traditional solution. But you know that in some cases, this is not so easy to provide the AC power, for example, in the IP phone. Let me to explain one real scenario. Assume that in our company, okay, we have 50 PCs, okay? And each PC is residing in one desk. For example, here we have one desk, okay, or one, for example, table. In this table, we have one PC. And also, one of our employees is working with this PC. Assume that we have, for example, 50 tables. And in each table, we have one PC. Okay, this is our company. Now, we want to implement the IP phones in our company. You know that Each person, each employee needs one IP phone. Because of that, here we need to give to each person one IP phone. This is the one IP phone. And because we are installing the IP phone on the table of the, for example, each person, each employee, we need to supply the power in each, for example, table. This means that if you have 50 PC, actually you need 50 IP phone and you need 50 more power outlets. And this means that again you need to construct the power, and after that for example you should install some devices about the supplying the power in the near of the table of the employee, and this is not so easy. Also, you need to generate the power also for all of these new power outlets. Okay, because of that, now we have a problem. For each IP phone, we need to, for example, supply the power. This is not so easy. Okay. After that, we have another type of devices that needs power. For example, the one IP camera. What is the IP camera? IP camera is a device that you can install it on the, for example, a ceiling, and after that it can record, it can monitor the area for you. Also, we have another device, access list or access points. Okay, IP access points, and the access point is the device that you can provide the, for example, RF or the wireless signals to the specific cell, and after that the wireless clients can connect to the access point. You know it, okay? And now we have again the other problem. The problem is that on the ceiling that we are installing the access point and IP camera, it is not so easy to install the power outlet. Okay, we need some wiring and some other thing. Because of that, this is not so easy. Now we have one important for example, a problem. The problem is that how we can supply the power for all of the devices in our networks, for the IP phone, for the IP camera, for the access points, and some other new devices that we have in, for example, one network. If you want to use the traditional solution, the supplying in each place the AC power outlet, this is not so easy. Okay, and also maybe this is requires to for consuming many for money resources, and this is not good. We have one solution. This is the intermediate solution. This is not a final solution, but if you want, you can use it. Look at here. You know that we are connecting IP phone directly to the switch. Okay, we have some devices, we call them power over Ethernet injector or PoE injector. Here, this you can see one PoE injector. This PoE injector can connect to the power or to the, for example, one power outlet or UPS uninterruptible power supply. And instead of connecting the IP phone, the IP camera, the access point directly to the switch, you can connect these devices to the power injector, for example, here. And after that, the next interface of the power injector can be connected to the switch. Actually, when the traffic is going from the switch to the for example, IP phone over the Ethernet cable, this power injector should inject the power into the UTP cable. And because of that, in one cable, we are receiving both power and also the data. This means that we don't need to install one new power outlet near the IP phone, near the access point, near the, for example, IP camera. Look at here, let me to explain it. You know that normally the switch should connect to the IP phone. And here we don't have any power. If you want, you can install between the switch and IP phone one power injector. Okay, let me do a PoE injector or power over Ethernet injector. Okay, after that, this power injector now has power. Why? In most cases, we are connecting the power injector to the, for example, UPS or maybe the power outlet. This is the power injector should be installed near the switch in most cases. Okay, and after that, here we have the power, for example, AC power. Let me to write here. And when the traffic is going from the switch to the, for example, IP phone, the power injector in the middle of the path can inject the power, and after that now we are sending both power and data to the IP phone. This is possible, but this is not for example, best solution. Why? Because you need to buy multiple power PoE injector, and here you have for example you need to install them, you need to maintain them, and again we can say this is the intermediate solution. This is not a best solution. If you don't have any other solution, you can use it. But the best solution is using some type of switch, that this type of switch can send power over the for example UTP cable. We have some type of switch, okay? This switch hardware has this capability of supplying the power to the devices. This is the switch with different hardware. In the hardware of this switch, for example, in some cases we have more than one power supply. We have two power supply. The first power supply is for the switch itself, and the second power supply is for other devices. We call it the power sourcing equipment, or PSE, okay? Because of that, if your switch support the PSE or power source or power for example applying, you can use the for example UTP cable to sending both power and data to the IP phone. IP phone is the power device, or PD. Also IP camera is a PD, access point is a PD. Let me to show you. Look at here. Here, the 2960 switch of the packet tracer doesn't support the power. This is not PoE, this is not PSE, okay? You know it. In some cases, maybe in the other types of the 2960 in the real world, that switch support the PoE, but this switch in the packet tracer doesn't support it. Because of that, as you saw, I have connected the adapter to the AC adapter interface. Now, let me to use another switch. This is the 3560 switch of the packet tracer. This is a PSE. This switch can support sending the power because the hardware of this switch has this capability to the, for example, one power device such as the IP phone. Look at here. When you are installing again one IP phone, this is the IP phone, and if you are connecting this device to the for example PSE without the need to connecting the IP phone with the power adapter to the AC power, the IP phone now is for example turning on. Look at here. As you can see, now the IP phone is working. Why? Because the PSE, this switch now can supply the power of this device. Okay, the configuration is beyond the scope of CCNA, but only for informing. Let me to show you here in this device, in the switch, you can use the show, for example, in show power in line command, show power, and then in line, it can give you enough information about the power. Here you can see on the port facet in 01, now we are offering power, 10 watt power to the IP phone 7960. And this means that this switch is the PSE switch with the capability of the PoE, but the 2960 in the packet tracer doesn't support it. Because of that, we don't have the command show power in line. Why? Because this is not a PSE. And also in this picture you can see the power sourcing equipment PSE connected to the IP camera, to the IP phone, and also some other devices. Also in the switch that support the power over Ethernet, here you can see one statement about the PoE, for example PoE or PoE plus supported, and after that here you can see a yellow line. Okay, this yellow line under the ports means these ports are the PoE ports, and you can use these ports for supporting the for example PoE, for giving the PoE to the other device. Also here you will see the PoE label. This means that this device is a PoE capable device. Because of that, this is related to the hardware of the switch in most cases, and if the switch doesn't support the PSE, okay, or the power over Ethernet, you need to replace the switch with newer switch in your design. Also, maybe in some cases we are using the power injector, but it's better today is that we consider the requirement of the powers when we are designing or choosing the switch for the, for example, network. About the PoE, we have another consideration. This is so important. You know that some device such as the IP phone, such as the access point, needs the power over Ethernet, okay? But some other device such as the network interface card of one PC doesn't need the power, because the power of the network interface card can be supplied with the power of the PC, okay? Because of that, if you apply the PoE to the network interface card of a PC, maybe the network interface card is corrupting, and maybe this is a, for example, consideration for the PoE appliement. You know that first we should understand that the other side needs the power. After that, we can apply the power. This is so important. I'm going to talk about this operation. Look at here. When you are connecting one device to one port of the PoE capable switch or the PSE, okay, first we should experience a negotiation between these two devices. After the negotiation, the switch can understand that it should apply the power to this device or not. Okay, don't forget, if you apply the power to the device that doesn't need the power, it can damage the device, and it is so important. This is the current more than the need of the, for example, one device. Because of that, first we have a negotiation between these two devices. If the negotiations result is that this is a PD, this is a powered device, you can apply the power to that device. The question is that how the switch can negotiate with the other side. Let me to emphasize that this is related to the, for example, the level 1 signaling, but also with the auto negotiation features of the Ethernet interfaces, we can talk about the PoE capability with the other device. But you know that first the other side interface should be enabled. After that, we can talk about that. For example, about the PoE. For example, in the IP phone, by default, this interface is shut down. And if you send negotiation message to the other side, okay, you don't have any, you will not have any response. The solution is that we can apply a small signal to the other side. If after that we can negotiate the parameters. Also, let me to emphasize that we have some electrical methods for understanding the other device is the PoE device, is the PD or not. For example, you can apply a little voltage to the 2 pin of the device in the switch, and after that you can calculate the resistance of that device. If the resistance is a specific amount of value, this means that is the powered device, and if not, that is not a powered device. Or maybe in some cases we have another solutions. For example, in more powered device, when the device is off, okay, the pin in and pin out are connected to each other. This means that the device is residing in the short circuit status. Because of that, if you send a little signal to the other side, you will receive the other signal, and this means that this is a powered device. Also, we have another for example, options for detecting the next device is the powered device or is not a powered device. This is not important for us. This is the electrical communication, but we should know that by default switch doesn't apply, okay, power to the other side. First, the switch should negotiate with one method, okay, the method is not important, with the other side. If the switch determines that the other side is the power device, it can apply the power. Because of that, for example, this switch now is applying the power to the IP phone, to the AP, but not to the PC, and it is so important. Look at here, in this scenario, you know that now the switch is applying the power to the, for example, 7960 switch, or IP phone, okay, but if you connect the PC, the switch after negotiation understand that the PC0 doesn't need the power. Because of that, it shouldn't apply the power, and it shouldn't apply. Look at here in the show power inline. Here in the show power inline command, you can see that the port 2, okay, now doesn't use any power, but the port 1 now is using for example the 10 watt power. Okay, because of that, now we know that the PSE device understand the other side's requirement. If the requirement of the other side is receiving the power, the PSE should give the power. If the other side doesn't need the power, the PSE should not send power or more, for example, extra power to the other side. Also, after the for example, after enabling the power to the other side, we are using the CDP or LLDP, as I mentioned before, for negotiating the needs, the new needs with the other side. Okay, for example, here now the CDP is working and the power requirement of this for example IP phone is sending to the PSE. Let me to show you in the capture if we can find the CDP message. First here, this is the CDP. We will read the requirement of this for example the device. For example, let me to find the requirement of the 7960 IP phone 1. This is the 7960 IP phone 1 CDP message. Here in the CDP message we have many information. Let me to check the result in the packet tracer, and here we can see the CDPs, but the detail is not available here in the packet tracer. But in the real world, it can send that its requirement about the power or other important features. Because of that, after identifying the device, the other side needs power or not, okay, with the CDP and LLDP again simultaneous in interval times, in by default 60 seconds. You know, in the CDP we are using 60 seconds as the interval, and in the LLDP is 30 seconds as the interval. We are negotiating about the need of power with the other side. If the other side needs power, we are applying the power. If the other side doesn't need the power, we shouldn't apply the power. It is so important, because if you apply the power to the, for example, one interface, one device that doesn't need power, maybe that device is for example corrupting, and after that you cannot use that device. The next things that we should know about the PoE is that the PoE has different versions. First, let me to give you a little history about the PoE. You know that first the Cisco was created the concept of creating or applying the power over the Ethernet cables, and the name of the technology around 2000, okay, the year 2000, was Cisco Inline Power or the ILP. Okay, after some years, okay, the IEEE introduced the standard I802.3AF, okay, and after that the name of this standard is the PoE. Okay, you can say the power over Ethernet or IEEE 802.3AF. Okay, in the Cisco ILP version, we are using the standard of Cisco. This is the Cisco proprietary, and maximum 7 watts can be given to one device. Okay, and we are applying this power, providing this power over 2 wire pairs. Okay, in most cases, you know that, for example, in Ethernet cable we are using the pin 1, 2, 3 and 6 for in the old days, and with the port pin 4, 5, 7 and 8 we can apply the power to the devices. And because of that, here you can see with 2 pair means 4 wire. Okay, we can apply the power. This is the old standards, and only old devices now are using this for example standard, because you know that the 7 watt is not so much for newer capabilities, for newer devices. Okay, you know that when we are negotiating about the capability of the power with the other side, one of the things that we should negotiate is the class of the power that that device needs. For example, one IP phone needs some amount of power, and maybe one access points needs more power. Okay, because of that we have some classes of the power. For example, one of them is PoE. PoE or IEEE 802.3AF support up to 15 or 15.4 watts. Okay, again it uses the 2 wire pairs or 4 for example wire. Look at here, 15 watt means we can connect the devices with maximum 15 watt requirement to the for example device support PoE. Look at here we have one switch. In this switch, you can see this switch support PoE, power over Ethernet 48 in 48 ports, in all of its ports. But PoE means that this switch can supply only the 15 watt in each port, not more. If you connect a device with the need more than 15 watt to this port, the device cannot, for example, enable, and you cannot use it. This is the PoE, okay? But if your device support the next standard, IEEE 80380, okay, PoE plus, we call it PoE plus. Some of the switches now are supporting the PoE plus. Your device support a standard 802.380 and can supply the 30 watt at each interface. Again, we are using two powered wire pairs. Also, if your device supporting UPoE, means universal PoE, your device supported the IEEE 802.3BT. This is the universal PoE. Okay, universal PoE can supply up to 60 watts on each port. And finally, for example, newest technology is UPoE plus or universal PoE plus 803BT again, can supply up to 100 watt at each interface, and both of them, UPoE and UPoE plus, are working with, for example, supplying in all of the four pairs. It is not we don't have any problem for supplying the power and data simultaneously in one link, okay? Because of that, don't worry about the four powered wire pairs. This is related to your device that support which of them, PoE, PoE plus, UPoE, UPoE plus. Actually, if your device support PoE, for example, cost of this device is lower than the PoE plus, than the UPoE, and then UPoE plus. For some reasons, for example, connecting some video conferences systems or some other, maybe you need to use devices that support UPoE or UPoE plus. For some, for example, lower needs, such as the IP phone, such as the IP camera, maybe we can use PoE plus or PoE. Because of that, when you are designing your LAN, you need to consider which devices will connect to this switch. According to this requirement, you can select your switch. You know that maybe you are buying 12960. This 2960 doesn't support PoE, for example. The cost is, for example, assume that is $100. It is not real, only for one example. But if you want to buy 2960 with the capability of the PoE, maybe it costs $200, okay? But if this switch support PoE plus, maybe the price is the $300. Because of that, this is so important, selecting the, for example, correct and suitable model of one switch according to your need. If your device is working in one area that you need more power, maybe you need to buy a UPoE or UPoE plus switch, supported switch. This means that you need to, for example, invest more than other rooms about the switch that you are using this room, okay? Because of that, when you are designing this the LAN, one of the considerations are this PoE and capability of PoE. You know that this is a hardware capability, not a software capability. When you are choosing your device according to your need and your, for example, required cost and required investment, you can choose your switch, and after that you can use it in your area. Don't forget that the impact of the PoE on the cost is not so small. It may be the impact of the PoE and the model of PoE is so high in your cost in buying the switches. You know that by using PoE or power over Ethernet, companies can gain several advantages, including reduced cost by requiring fewer cable runs and better power management capabilities as compared with using a traditional electrical power cable run and power outlet. Okay, let me now in the last section of the PoE in this video give you some recommendation about the PoE and also the LAN design. First, how we can choose the switch model, and also for example use this switch model in our networks. About the PoE, you can consider these factors. The first is power device. You need to determine the type of devices that you are using in your network, and also the models of that devices that you are using in your network, and also the requirement related to the power of that devices in your network. This is so important for choosing the for example switch model. After that, you need to think about the power requirement. You know that, for example, we have one PD device, and also maybe we have 10 PD device. You need to sum and also for example add the total PoE requirement of that device together, and with this for example sum, you can find the power budget that you need in one device. Let me to talk about that. You know that in one switch, okay, maybe we can provide 15 watt of power in each port, but this switch has a specific capability. For example, it can for example supply up to 100 watt of the power. This means that only 6 port or maybe 7 port of this switch can supply the power. Maybe you have the devices with 15 watt of the requirement, it's okay, but because you have, for example, 10 devices with 15 watt requirement, you need 150 watts of power. Because of that, you should consider the total PoE or power over Ethernet requirement, and after that you should choose the device, the switch for example, with the compatibility of the total PoE requirement that you have. Because of that, you need to first identify the devices or the PD devices that you have in your network, the number of that devices, okay, and finally you can choose a switch that can provide the power of that devices in each port, and after that the total power of that switch should be for example at least equal to the total power of the need of your devices. Also, in some switch ports, we don't have the capability of PoE. For example, maybe you are buying one switch. In this switch, we have 24 interface, 24 ports, okay? But only 12 ports of this switch support the PoE, and other ports doesn't support the PoE. We can say 12 ports are PoE or power over Ethernet capable, and 12 ports, okay, are non-PoE. This means that you cannot connect to these ports the PoE devices. Because of that, you need to consider the number of switch ports in your device that support the, for example, power over Ethernet. Also, the switch power supplies, this is exactly the same thing that I have explained before. You need to consider that this switch is a PoE capable, and also the total power of this switch is for example sufficient for your requirement. For example, here, look at here, in this switch, when you are using show power in line, you know that until now we have used only 10 watt of power. Here we have available power, this is the total power, or maybe the default power that we have in this switch, 370 watt. Because we have used 10 watt, only 370 watts of power now is remaining. Because of that, you need to consider the total power that you need in your network. And also we need to for example consider the PoE standards, means IEEE 8, OTA 380, 3AF, and also 3BT, okay? And after that, you can choose the correct standard, the correct switch capabilities for your device. For example, I have a device with requirement of the IEEE 8 OTA 3BT, okay? And because of that, we need to buy a switch with the capability of the UPoE at least or UPoE plus. Here you can see PoE standard versus actual. What is the meaning of the actual power requirement? You know that, for example, we have a switch with the, for example, PoE capability, means 15 watts, okay? This is a switch. the port of this switch can supply the power, the 15 watt, but our device, our PD only needs 7 watt. It's okay. We can apply less than or lower than the maximum available power on one port. Okay, it's okay. And with the negotiation with the CDP and LLDP, the switch can find which amount of power is suitable for the device. After that, this negotiation should be occurring during the time. If the requirement was changed, again we should apply maybe the other amount of for example power over Ethernet. Here in the packet tracer, you can connect the device, for example PSE, to multiple switches, to multiple for example PoE devices. One of them is IP phone, and let me to find another devices here in the wireless. Okay, we have some for example access point. This is the access point. Let me to connect the AP. In the AP here, now we have the connectivity to the power. It has power. And also in the lightweight AP, this is the lightweight access point. Here we have adapter. Let me to connect this lightweight access point, okay, to the for example switch. This is the PSE switch. I'm going to connect it to the lightweight access point. As you saw, I didn't connect the adapter to the access point. Now in the PSE, if you check the show power in line, okay, show power in line, you can see that this access point now is using 15 watt, but the for example IP phone is using 10 watt. Here we can see the class of the for example class of the IP phone, and the here you can see the maximum power available in each port of the PSE. You know that this switch is a PoE, and PoE can support 15.4 maximum power, and as you can see the iPhone is using 10 watt and the access list is using the 15 watt. Or maybe you have another device that needs a lower amount of power, and because of that we don't have any problem, because the switch can apply lower power, but the switch cannot apply more than 15 watt in one interface. Don't forget, if you attach for example one device with the requirement of the 30 watt power to one interface, that device cannot work and the device cannot be enabled. Okay, this is the PoE in the CCNA, in the level of CCNA, but let me to emphasize that about the PoE, we will learn more than this in the future. PoE is not a concept, PoE is a tool, and we are using the PoE, okay? PoE is different with the, for example, STP and some other concepts. PoE is a feature that we need it. Okay, for using the network is more easier and also more efficient. With PoE, you can easier manage the, for example, power in your network, and the cost of the supplying power for the devices will be reducing. Very good. In this video, we have learned about the LAN architecture. You know that I have explained the campus LAN topologies and also the SOHO network, and after that finally we have learned about the PoE or power over Ethernet. In the next video, I'm going to talk about the WAN architecture. This is the LAN architecture, means local area network architecture. In the next video, we will learn about the WAN or wide area network architecture. In this video, we didn't configure anything. It's okay, but it's important to understanding the concept of this video for learning the WAN architecture. Because of that, first, review all of the content of this, for example, video. After completing all of the concepts, if you want, you can take some notes. You will be ready to learning about the next step, the WAN architecture. You know that in one enterprise we have LAN and also we have WAN. Now we have for example view about the LAN architecture. Let me to talk about the WAN architecture in the next video. Because of that, after reviewing all of the concept of this video, please come with me to the next video. I'm going to talk about the WAN architecture.